Hello and welcome to the DevOps session. My name is Prasanjit Singh and today I'll be taking you through Amazon Cloud Overview. So, what are we going to do today is to understand and have a basic tour of Amazon Web Services Cloud Console. So, we are going to learn what are the different features available in the Amazon Cloud and how we are going to use them and how then we are going to implement our DevOps practices in the Amazon cloud. So that is what we are going to do today. We are not going to go deep into any service of Amazon. We are just going to have a preliminary idea of what Amazon cloud means and how we can use them to implement our production workloads, to implement our pipelines, and to deploy our services in Amazon. So this is just a primer, you can say. Once we know what the cloud is, then we can move on and do courses which take us deeper into what are the various services and implementations that can be done in the Amazon cloud. So this is just going to be a primer, but I hope you will like the course and learn something from today's lecture. So what is the agenda here? The first thing we'll understand is what's a cloud. What does that mean? We already hear a lot about cloud nowadays, and most of the services are hosted in the cloud, unlike the earlier days when people used to host their services and applications on premises in the hardware servers placed in their own offices. So on premise has now moved into cloud computing. So we'll understand what that is. Then we'll understand what AWS services are, like what does AWS cloud comprise of. And for those who are not aware, AWS stands for Amazon Web Services. So this is what the Amazon cloud is otherwise known as. Then we'll move on to understand one example architecture which is deployed on Amazon cloud, and we'll also have a tour of the Amazon console and see how to create instances in the EC2 service and what are the different dashboards in Amazon looks like and how to use them. So we'll just have a basic understanding of this Amazon dashboard or the Amazon console, and then obviously we'll create a couple of instances and we'll see how we can connect to those instances and run our commands there. So we'll be creating a couple of Linux based instances. So once we are acquainted with all this knowledge will come handy in our upcoming sessions where we will be deploying our services using pipelines, and we would be implementing Ansible scripts and configuration management tools to deploy stuff. We'll be learning about Terraform and creating these cloud instances using our Terraform code. So we'll be practicing infrastructure as a code there. So that would open us a lot of avenues once we learn what a cloud is. And once you get a hang of any one public cloud like Amazon in this case, you would be able to work on other public clouds as well, like Azure or Oracle Cloud or GCP. So let's get started with Amazon Cloud in the lecture today. So first of all, let's answer the question, or rather find the answer to the question, what is cloud? So before I move on to this diagram that you see in your screen, let me just talk about cloud in simple economic terms. Like, what is a cloud provider? How does the cloud provider make money? That is the most important question. And then we understand whether that model is a viable model or not, and why we adopt a cloud, or why we start using a cloud for hosting our applications, and how does a cloud provider gain from that, and how do we gain from that. So if it is a win-win for both sides, only then a business works and a technology obviously succeeds. So first of all, let's imagine a scenario where you have a web application, you have a website. Let's for example assume that we have a sports website, and we live stream matches that go around the world, and we make money from the advertisements that we show in our live stream matches. So say this is our business model, and our service is hosted in bare metal servers. Like we have bare metal servers on premise in our office, and we are hosting our streaming application on those servers. Now just imagine, like a situation comes when there is a big sporting event going on, like a World Cup, uh, or there is a festival around the corner, or a long weekend. So there are lots of customers who are watching this particular match going on, because it's a holiday or it's a big match. So in those cases, we will see a sudden surge in the number of viewing sessions. Like we will have a lot of people viewing our website, in simple terms. So when such a situation arises, our website might go slow and need to be scaled up. Like 1 or 2 servers would not suffice in that case, and we'll need to add more servers. Now, if we are hosting it on premise, then adding new servers means buying new hardware. Like we will buy a new server, set it up, install the operating system, put our softwares, connect it to the existing cluster, and then scale up our cluster so that the new server is accommodated, and we can take care of our customer, I mean newly acquired customers, and provide them a good viewing service. Now, don't you think this is too tedious and costly? Because buying a new server would be a big cost on your capital, and then obviously configuring it would take time. You would need people to with the know-how to manage a server hardware, the software and everything. Like it's an overhead. So this kind of a structure is not very viable, like, because another reason being, uh, for your business, this surge in the number of viewership is temporary. Like once the World Cup is over, or once the weekend is over, the number of customers watching your website will again drop down until the next occasion. So now your investment on this new server is not worth it, because you don't have customers anymore after that event where you saw a surge in traffic, but you are still having to pay the installments for the server you bought. So this doesn't work out very well. So in these cases, it would be much better if people hire out their servers. Like people rent out their servers. So that is what a cloud service provider does. It has a pool of thousands of servers from where you can take a few servers on lease, and you are paying only for the time for which you are running your service on the server. So when you stop the server, you're not paying anymore for it. So you may pay for the time. It's similar. You can take it with an analogy to renting out an apartment. Like you stay in an apartment, so you're paying your rent for the time you stay there. Once you're out of that apartment, you no longer have to pay the landlord. So that is how uh, it works in the cloud world. So what is a cloud essentially? It's a pool of resources. Like there's a cloud provider who has hundreds of thousands of servers all connected together, and having a hypervisor layer, having operating systems installed and all that, and he is renting out the servers of different sizes and models and hardware specifications, and the person who takes it is the account holder and pays it for the time that he used that cloud. Now, this isn't actually that simple. Okay, there are other layers to it. So what are they? There are various ways in which this cloud business works. So one of them is it is called IaaS, Infrastructure as a Service. So what does that mean? That means the infrastructure or the bare metal is provisioned by the cloud provider and provided on a rent basis, like pay as you use. So you pay for the amount of time you use, like I said some time ago, and it is on you to take the infrastructure and do whatever you want. For example, you can have your Windows operating system installed on it, you can have Linux installed on it, you can then install your database, application, server, whatever. You only pay for the hardware and you take care of the rest of the layers. Okay, and they only ensure that your hardware is up all the time, or as per the SLA, and the power is up, everything is working fine on the hardware end. So that is how infrastructure as a service works. Now if you go a step further, like you don't want to take care of the server as well as the operating system, that is also possible. So in that case, the cloud providers have a model called platform as a service, where what they do, they have the infrastructure and install a platform over it, for example say Linux, and sometimes even the platform is added with some additional libraries, like for example you might have Java installed on it, or some basic layer where your application would run on. For example, you have a Node.js application, so the libraries needed would be already pre-installed, and you just have to put your code and keep working there. So this kind of a arrangement is called platform as a service. So they give you a server as well as a platform, so the only thing you have to do is to implement or deploy your application and the databases. So most cloud providers now are working on a platform as a service model. There is another model of cloud which is called software as a service. So this is for companies who provide a software uh, as a cloud service tool. For example, Gmail, enterprise accounts. So for example, you have a company and you have 50 people in your company and you would need 50 email accounts, corporate email accounts, not the normal @gmail.com ones. You would need a corporate Gmail account with your domain name. For example, you have a company xyz.com, so your email should be username @xyz.com. So for these kind of arrangements, you get a G Suite or Google Suite uh, account, and then you get it for 50 members, and uh, you get 50 email IDs to operate and different G drives and so on. So this kind of arrangement where you do not have to care about the servers that is needed to host those 50 accounts, you do not need to care about what application should be installed to have the Gmail, mail functionality working and all that. You just have your users and passwords and you start using them. Similarly, there are other software as a service providers like Salesforce, which provides CRM. There is a Zoho application which provides Zoho CRM as well as mail and other softwares as a service. So this is another model of cloud where you can buy your accounts for your company and start using them right away without delving into the software or the hardware layer. So it is only the application you are bothered with. So that is the software as a service model. Now coming back to this diagram, what do we see here is multiple hardware servers are pooled together. So this is a pool of resources, hardware resources, over which applications and databases are installed. So this comprises a cloud. So a cloud provider would provide normally hardware resources, sometimes hardware plus a bit of application libraries. Now you have to deploy your app and databases on it, and the cloud provider would also ensure access to your cloud servers to the internet, so that your customers or your users can access to your applications and resources from outside. And another thing that is important in the cloud is flexibility. Like, one thing is it allows you to save your expenditure, which is what we discussed in the first example where we were having a sports website, and we would not have money to buy servers again and again, so we use cloud. So that is one advantage cloud provides. It reduces your capital expenditure. By capital expenditure we mean the amount of money or capital we spend on buying resources, okay, buying assets. So using a cloud reduces your capital expenditure but increases your operational expenditure. Like, you spend money on your operations, like you pay your developers to develop your website, you pay your DevOps personnel to set up the DevOps pipelines and take care of the deployments and all that stuff. So but that is comparatively much less than the capital expenditure which you would have to pay had you bought and installed servers on premise. So that is one advantage cloud provides in terms of economics. Another advantage it provides is it is flexible. That is why cloud services are also called elastic. Like, you might have heard the term elastic compute service, uh, which we call EC2 as well, to Amazon services. So the term elastic means flexible. So cloud servers are flexible, so you can increase or decrease the number of servers, or you can scale up or down according to your requirements and on demand. Like, whenever you need, say, to scale from 50 servers to 100 servers, you can go ahead and do it right away. So that is how cloud helps to have a very good elasticity. So if you have a surge in traffic in your sports website, for example, you have 5 million users watching the match at the same time, and suddenly there is a surge of 3 million new users coming in, and you do not have resources to do it on premise. If you're hosted on cloud, you could do it on the go. Like, you just launch some set of scripts to scale up your servers to take care of the new 3 million customers that have logged in recently. So that's how big websites or applications survive. You might have heard about Twitter having millions of concurrent users using it in times like the New Year, or the Xmas Day on 25th December, and so on, when people send the greetings to each other and so on. So in those times there is a huge surge of traffic in these websites. So how do they take care of that traffic and do not ever go down? Or Google search, like almost every person who uses a computer would first open his browser and open up google.com. So that is the amount of traffic that comes into Google search engines. Like, billions of sessions would have been created at any point of time. So how does Google take care of all that traffic without going down? So for these kind of situations they use cloud. So cloud provides a very easy way to launch new instances or containers, so that all the traffic is taken care without downtimes. So that is what cloud is. So if someone asks you what cloud is, you can simply say it is a pool of resources. Like, you can say it's hardware servers all connected together, and they can be it is I mean, you are flexible to create different clusters out of those servers, create separate isolated groups called virtual private clusters, and so on. You can have your databases there, applications there, and it has various features. Like, it is elastic. It allows you to create your servers on the go, on demand, and it also provides you a great economic advantage over maintaining your own on-premise hardware solution. So there are lots of facets to a cloud. So that is what cloud is. And because of the nature of the cloud, by cloud we mean like it's centralized as well, like you can have everything centralized as well as distributed. For example, a cloud has various regions all over the world, so if you want you can disperse your application distributed over various regions so that your customers can access your application from the nearest region. So we'll talk about all that in a while. So by now you get a brief idea of what cloud is. So let's then move on to various services that comprise the AWS cloud. Now this slide has various services grouped together, uh, and it shows like what are those services which comprise the Amazon Web Services. So before we go in on and discuss these services, let's have a look at the Amazon dashboard. So that will give us some idea, and I'll talk about each of these services so that you get an idea of what kind of services are available. So then this particular diagram will make more sense to you. So moving on, let's go through to this console, aws.amazon.com/console. If you go there, then you would be asked to create an account if you do not have, otherwise you won't be able to log into the console. And once you create the account with all your details, and you would also need to provide your credit card details, but make sure to choose the free tier option if you are using it for the purpose of learning only. If you are using it for your enterprise, then you would have to choose for the enterprise option. If you choose the free tier, you would get access to almost all the services in AWS, and it would be free for 1 year. There are certain conditions that apply. You can go through them while creating your account, and there are certain restrictions as well, like you cannot launch just any instance type. There are certain specific instances which are under free tier, so you have to use them so that you are not billed. If you use something outside what is under the contract, then you would be charged. So what I have done is I have already created my account, so I can just directly sign in. But if you haven't created, you can click here, create a new account, and then come back and sign in. So I'll just click sign into the console, and I have my password saved in my browser, so it won't prompt me. So I already had the session active, so I have directly logged in. So now the page we see is the AWS Management Console. So this is from where you can manage various services that are a part of the Amazon Web Service Cloud. So let's go through what services are there and what are the most essential services and most commonly used services. So here are the services. You can directly search for the name of the services if you know them already, so it will take you to that particular service. Or if you do not know, you can click here and you get a list of services here, and you can move on to whichever service you like. Okay, so this is how you move on to your service. Here there is a wizard which will launch some short and useful tutorials about various services. So you can spend some time here and look at what are the offerings and how you can use them and so on. So there are lots of tutorials that AWS provides, so you can get free training as well watching those videos, and later on you can plan having AWS certifications as well. But appearing for a certification is paid. Training videos are available in AWS, so you can even click on these links and go for self-paced online courses and so on. But it is a bit difficult to uh, I mean get started if you are starting from scratch without any prior knowledge. So in that case you would need a mentor for some time. But once you are in the waters, then you can take care of yourself and learn more and do it yourself. All right, so let me get you started then. So first, let's discuss what are the important services that are part of AWS, and then we'll start using one of the service that is called EC2 and launch instances. So let's first discuss normally what are the common services that are in AWS. So here you can see the different names of services, and there are some headings like compute, storage, database, and so on. So these are commonly used service heads like compute, storage, database, migration, and transfer. So all that in the left hand side are commonly used by almost all the companies who host on Amazon cloud. So I'll talk about these in the end because we'll have to learn more about these things. So let's first understand what are the other components here and the other services. So other services which are here are domain specific. For example, blockchain is about the ledger based system. Like you can have a blockchain system used by various banks, where you have some accounting to do and so on. So you use these kind of algorithms. So this is only for banking, bitcoins, and all those kind of organizations use blockchain technology. There are other organizations that have started using this, but normally it belongs to that niche. Not all organizations will use this technology. Similarly, satellite services, quantum technologies, these are some good practices and exploration tools. Here are certain services which are related to media or video streaming industry, so only those companies use these services. Machine learning services, they have a great set of machine learning libraries, and we would be doing some machine learning videos very soon. So you would if you are following the videos I make, then you will see a great lot of machine learning videos as well upcoming. So this is for the machine learning industry, like ML and AI, where you have to build models and predict outcomes of certain events going on, and do some recognition tasks like video recognition, facial recognition, then and lots of other pattern recognition and so on. So there are lots of possibilities in these services, but again, as I said, these are not very commonly used services unless that company is doing something in these lines. Similarly, there are other services like analytics. These are followed by big data companies who analyze data and do business intelligence out of it. For example, there are companies who predict things, or who do various surveys. Like I always speak about this example of Nielsen, who take this is a company which takes surveys from various entities and create their polls, and they predict certain things like who is going to win the election, or who is going to be the next president of United States, or anything under the sun. So analytics helps to predict all those things and create graphs and dashboards for management to understand. So this is about business analytics, so services related to it. And these are different firewalls and security measures. So using these services allow you to keep your application secure. And similarly, there are mobile services, VR services, and lots of others. Like, you do not have to know all the services, that will come with time. Wherever you join those organizations, if they are using a service, then you would start using it. And all the services Amazon adopts are very self-explanatory. So you just go through the documentation, and the dashboard you get would be very straightforward. Like you keep doing it, following one thing leads to the another, and you finally you will see you are able to do the stuff with very little assistance. So that way you can learn. Once you play around with the dashboard, you can learn. Now let's go through the essential services which almost everyone would use when he uses Amazon Cloud. So one of those services is EC2. Okay, so using EC2 we can launch our instances. By instances I mean virtual machines, like we were doing for with VirtualBox in our previous sessions. We were creating Linux instances there, installing Ubuntu and doing our stuff. So similarly, if you are on a cloud, you can go to EC2 and create your own servers. All right, and you pay by the hour for the server, like whichever configuration you choose. If it is a bigger server with higher configuration, then you pay more per hour for that particular server, and so on. And for the present case, we are using a free tier account, so we'll only use those instances and which are covered under the free tier, so we would not be paying for it, at least for 1 year. So that is about EC2. Similarly, there are other services like Lightsail is very less used, like it is for creating VPCs, virtual private servers, VPS, pardon me. And there is Lambda, where you create serverless applications. For example, you have certain tasks which you do not want to run all the time, because if I launch a server, that would have to run 24/7, or I have to have someone stop the server after I run the tasks. That is normally not viable. So normally if you have your website hosted, you would not want to stop the server, you would have it running 24/7. So Lambda is a service which runs serverless, so you can run your workloads which run say a couple of times a day or are triggered based on certain events. For example, you want to send out a mailer to a group of your customers. Like every Sunday, you send out a newsletter to your customers that these are my new things that have come up in my particular business. For example, you might have got these kind of newsletters lot of times, like Amazon or Flipkart, these kind of shopping sites. They send you notifications with what new items have come up or what is discounted for that particular week. So you might have got these kind of promotional emails weekly. So when these emails are triggered, they might be triggered by a certain function or code. So now once the mail is sent, now does this particular service or microservice have anything to do until the next week, assuming that these mails are sent out weekly? So once the mails are sent to my 1000 customers, my service is done with its job. So there is no point of running this service for the whole week, because the next mail batch will be sent on the next week. So these kind of jobs normally would not need a dedicated server to be run. So you can have Lambda function set up. So what it does, it creates a instance, launches that service there, and we do not have to take care of that instance. We just have to launch our function there. So it launches that function. Once the task is over, it kills everything, and we do not have to pay anything for it. We only have to pay for the amount of time our function ran on the platform or Lambda. So this is a very cost saving option as well, if you can use it correctly. So similarly, there are other services like Beanstalk, which provide you a platform and environment for your service to run. There are Outposts, where you can host your applications on edge servers or on-premise servers and still connect to the cloud. So there are lots of these kind of services, but as I said, the most famous one is EC2. So for now, you should concentrate on the EC2 service. Whenever time comes, you will learn more about other services, but initially you would not need anything other than EC2. Similarly, another important service is S3. Okay, so S3 service is an object storage service. So if you have big files, like large files, terabytes in size or gigabytes in size, and you want to store it as a backup or something, then it would not be wise to store it on hard disks, because in the cloud you pay for the EBS volumes. By EBS I mean elastic block storage. These are nothing but hard disks. So if you're storing a 250 gig data in your hard disk, so you are paying for that amount of space that you are consuming in a cloud premises. So that becomes very costly when you have a lot of archival data. For example, there is a university which has its alumni list and the report cards and all the different theses that these guys submitted and so on, and everything is digital. Now say every year there are thousands of students in that university, and it has to archive all their data just in case someone loses their certificates or something and wants to retrieve it after a long period of time. Say a person comes up after 15 years and asks for his certificate which he has lost, so the university has to maintain some sort of records somewhere and archive it. There are other archival data also, like for example, say New York Municipal Corporation would be having its record of births and deaths. So they cannot delete these kind of data because these are government statistics. So it might be maintaining all the data right from the 1920s to 2020, like 100 years of data. So there should be some space to archive that amount of data. So if you keep it on a hard disk, it's not very viable, I mean not even economic. So in these cases you use something like an object store called S3, and if it is having a long retention period, you can even use a cheaper option called S3 Glacier. So there the retrieval time will be more, but storing it is very cheap. Okay, so S3 and Glacier, these are our object storages. Similarly, there are other elastic file system, storage gateway, and other tools which are used to help in the storage functions. So S3 is the thing which you would be concerned about mostly, just like EC2. So just remember about S3 and EC2 when you are doing AWS. Most important are these at this point of time for you. Similarly, if you want to host a database and you do not want to run your own MySQL server or your own PostgreSQL server, then you can use RDS for MySQL MariaDB, or you can use Amazon Redshift if you use a PostgreSQL server. So these are various open source servers which has been adapted into the Amazon environment, and they maintain the control plane for this service. By control plane I mean you do not have to worry about whether your database server is running or not. You just have to worry about what you are going to store inside the database. So there you have a very good advantage, like you don't have to take care of the database internals. You do not need a DB admin to take care of the database, take the backups, or if something goes down to restore it and all that. So Amazon takes care of everything. You just are given a database connection endpoint, port, a username and password that you configure, and you can use it just to log in and create your databases and start using it. So that is how. So now you might be feeling a bit lost, not being able to understand these tools, but when you start using them actually, then it would become very clear to you. For now you can just know these are various services, like as I said, platform as a service. These are various platforms which you can directly use to create your web application or to host your web application. For example, you will use EC2 to create a EC2 instance or a virtual machine where you host your application. You can create a RDS instance to host your database, connect your app to your DB so your website is up. Whenever you take backups, you store it on the S3 buckets and so on. So you can use multiple services together to make your website work or your application works. So that is how Amazon helps you to deploy your instances in the cloud and enables you to serve your customers well. Because whenever you have a huge traffic, you can immediately scale up your instances here, or scale up your databases here, and serve your customers with optimal speed and good user experience. So that is how these AWS services work. We will discuss about how are various web applications hosted and how are different services being used in AWS, but that we'll do towards the end of this lecture. So first, now let's do some hands-on. So what hands-on we are going to do, that is, we are going to create a couple of instances in EC2 and install Ubuntu Linux on it, because we are using Ubuntu 18 in most of our almost all of our sessions that we have done. So we'll not break the sequence, we'll use the same Ubuntu, but I'll show you how you can launch any flavor of operating system you want. And once we launch the instances, we'll see how we will connect to those instances and do our job. Okay, so first you select the EC2 from the services, and then you land up in this dashboard, and here you click on running instances, and then we will be ready to launch instances here. But before you launch instances, let me talk something about regions and availability zones in a cloud. Okay, so here you see lots of menu on the left hand side, EC2 dashboard, where we are, events, it will show you what events are going on, tags like various tags that you create on your instances, we'll do that in a while, and similarly lots of other things. So these options will come in when we start doing more and more on the cloud. But for now, just forget about whatever is on the left hand screen. You just concentrate on few things. One is how to launch an instance, this we'll do in a while, and another thing is which region we are in. So in AWS there are various hierarchies. For example, one hierarchy is creating an account. So this is the account holder's name, or so if your company buys an account, so the company name would appear here, and so on. So account is the highest level of abstraction where you have access to the cloud and you are allowed to create instances anywhere in any region. Now what are the different regions available and what do they mean? In AWS you have lots of regions here, like these are all regions. US East is a region, US West is a region, Asia Pacific is a region, Africa is a region, Canada, Europe, Middle East, and South America. So these are various regions. So that means there are data centers in these places around the world. So why should we have multiple regions? Why not Amazon, being a American company, have it data centers only in the US? Why not? Why does it have all over the world? The reason being, in networking we have a term called latency. Like whenever you are accessing a site, that site would open faster if the path to cover and reach the server is lesser. So because ultimately everything is data is traveling through fiber optic cables, so the longer the distance it has to cover, the more the time it will take and slower will be your website. So if you have your website hosted on the US and you have your customers somewhere far in Australia, then it would have to cross the entire Pacific to reach the US, so it will take some time. So the website will open up a while later than how it will open up in the US if the customer is in the US. So for this reason, companies would always love to host their website on the same place where their prospective users are. For example, if I am having my sports website which is showing cricket matches specifically for Indian users, so I would like to host my server in Asia Pacific Mumbai region, so that my customers will be able to have a very good viewing experience and less latency. So this is the reason you have different regions and data centers in different regions, so that the connectivity and availability is best for the users in that region. So if you have a website which is catering throughout the world, and you have a lot of traffic from different parts, then you have to serve it from multiple locations. So that's why you have multiple regions. So big websites have their presence in multiple locations. It's not one server that is serving that big website. For example, Twitter, it would not be having just one cluster of servers in the US, because the people all over the world use Twitter, so they would have their servers dispersed all over the world. So this is just a simple analogy I'm giving, like simple understanding rather. So there are lots of other components also that go into this, not only the location of the server. There are other components like content distribution network, CDNs, CloudFront, and so on. We'll discuss all that later. I don't want to make it very complicated. For now, you just understand like there are multiple locations where your servers can be hosted, and normally locations are chosen based on where your traffic comes from the most, like wherever your customer base lies, you would like to host it on that region. Okay, apart from that, having multiple regions gives you redundancy. For example, if someone asks you to create a highly available website, so you would choose regions, of course, but you would not host your servers on one particular region. For example, if there is a natural calamity like a cyclone or earthquake, and for example say that particular region gets disrupted, then maybe the internet gets disrupted there, or there are power lines which do not work and so on. So then your website would go down if you are hosting it from one particular place. So if you are hosting it from multiple cities or countries, then it becomes highly available. So that is the reason you have multiple regions. Okay, and within those regions you have multiple data centers in various locations, like you have this US East, US East 2, and so on. So these are called availability zones. Like in a region you can have multiple availability zones. So these are isolated data centers in a particular region. Like if you have US East 1 and 2, that means both these are availability zones under US East region. Okay, so that is how different regions and availability zones are demarcated. So this entire thing is a region and there are various availability zones under it. So that is all about the regions and the account. So now let's get started launching the instance. So in order to launch your EC2 instances, you have to choose any of these blue buttons and click on them. So that will take you to a wizard. In this wizard, you can choose various options. There are various stages here. Choose AMI, choose instance type, configure instance, add storage, add tags, configure security group, review everything, and then start your instance. So we'll go through all these steps and I'll explain you what is what and what to choose when to install your instance. Now you can choose any operating system you want here, but since our exercises comprise of Ubuntu based operating system commands, so we'll choose Ubuntu. Now do not just go ahead and choose any Ubuntu version. Normally what I do is I choose the version that is just one step behind the latest version. I mean, this is not a hard and fast rule, but you can do it, like it depends upon your preferences. Why I do this? Because the latest version is yet not very tested, and nor there might be some unforeseen issues there, because we are planning to deploy something for production. So we should know the operating system inside out. So we should not go with this Ubuntu 20.04 at this point. If we are doing a production system, 18 is very stable and it has LTS support, like this particular image. So long-term service support. So we can use this one. This is safe for production use, and it is also free tier eligible. So because we are going to install a free tier instance, so we are going to use this. Ubuntu 16 might be a bit too old, so let's use this one. So we select the instance. If you are not sure like which one to select for the free tier, you can click here and also filter out only the free tier based instances. So our Ubuntu 18.04 also comes up in this list. So we select our operating system here. Most of the operating systems would be 64-bit, and we'll choose 64-bit instead of 32-bit because they have certain advantages over the 32 bits. They are fast, file system can store more number of inodes and lots of other stuff. So we choose that, and then we go on here and choose the free tier eligible instance. So here are lots of other parameters. This is the family. There are lots of families of instances. General purpose is for any purpose you want. There are other types like compute optimized. For example, you want to deploy something that is CPU intensive, then you would choose some instance out of these lists. If you want something which uses more memory, then you would use a memory optimized instance. If there is a write heavy application, like you write a lot on the hard disk, so you need efficient hard disks, then you use storage optimized, and so on. So there are lots of aspects based on which you choose your instance, and also you choose based on the economics. Like different instance types here will charge you differently. Like the smaller the instance, lesser the charge, and bigger the instance, more the charge. So there are servers which have 255 gigs 256 gigs of RAM and 64 core CPU, and there are servers which have just 500 MB RAM and 512 MB RAM and 1 core CPU. So this would be the cheapest one. But since we are on the free tier account, so we'll choose this one, so we would not have to pay for it. So we choose a T2 micro instance type. These are the name of the instance types. Okay, so you can read more about the instance types in this pop-up. Once you hover around any of these links, it gives you a brief overview of the instance type. And here you can see how much CPUs are there or how much memories are there for that instance type. So the server we will have one virtual CPU, 1 gig RAM. And here you can choose how much your hard disk would be EBS or not. So EBS, by EBS we mean elastic block storage. So we normally use the EBS nowadays, so we are going to go with that, and then we click on next. So that takes us to this page. Here you have other options like whether you want to create a separate network for your servers or you use the default network. For now we are not going to try out anything, we'll just select the default network. So it creates its own VPC or virtual private cluster. So it creates a small network and you have your own IP addresses, like internal IP addresses. So any server in the Amazon cloud or outside cannot access your servers with the internal IPs. It can access using the external IPs only. So each server will have an external as well as an internal IP. So it can access your server through the external IPs on the ports which you open. So your server is normally secure. This do not have any open ports. So you will define which ports you want to open. If it is a website, you might open your port 80 and 443. If it is a server where you want to SSH, you would open your 22 port and so on. So that step will come later. So here we do not change anything. Since we want to launch couple of instances, we just make the number of instance count to 2. So we will install 2 instances just to see how it works. Other options, no need right now. Okay, so just keep it as default. We'll understand each of these options later on when we do more sessions on AWS. So from a DevOps perspective, we just need to now launch 2 instances and get going, because we are just having a tour of what AWS is. We are not doing a deep dive here. Okay, so this is what we do here. Next, takes us to a screen where it is asking how much storage you need. So you can this is about the size of your hard disk. For example, in your laptop, say you have 500 gigs hard disk, so it is the same, like how much hard disk you want your server to have. Now here, since we are using a free tier, if we do not want to pay anything, we should have something less than 30. If you want to use more than this, then you will have to pay for the differential amount. Okay, so we just want to launch a sample instance, so I just make it 10 gigs. That is enough for Ubuntu to get installed, and we'll have some space to spare. And then we move on to add tags. Now this section is for tagging or labeling your server. For example, I will tell the purpose of the server. Okay, so I will tell server type, and for example, I want to create the server for Jenkins, so server type Jenkins. I can create an environment name, and I say this is a production server. You can create any other tag, like this is for you to identify what your server is for. Okay, so I can say I can have a team name if it is for a specific team. So for example, if DevOps team is going to use this server, I can tag it this one. So later on people can search, say, like for example, in the console, when you have hundreds of servers and you want to just list out the servers used by DevOps team only, or design team only, or so on, in big organizations, the tags help you segregate and identify your servers. Okay, so that is what tags for, it's just labels. Okay, and then get to the next screen, that is the security group. So this is where you can add your security group, custom group, or you can just use a existing security group. So I'm creating a new one for you to see what it is and how it works. So here you can do these are the various protocols and the ports that you want to open, and this is the IP address from where this port will be accessed. So if it is 0.0.0.0/0, that means this is the address from where you can this stands for all IP addresses. Okay, so if you want to access it from anywhere and you want to allow everyone to access, so you have to put this as your source IP address, like the source traffic will arrive from any of the address and then land in your port 22. So we are allowing SSH because we want to SSH into our server. Say we have a website which will be running in port 80, so we can open up HTTP port. So as soon as I choose HTTP, automatically it gives 80. If we have a custom port, for example, you install NetData, so it does not have a protocol, so in those cases you use a custom TCP. Okay, so if you put a custom TCP, then you can put the port where your particular service listens. So NetData listens on 19999. We had done this exercise earlier, installing NetData. So that way, whatever application you are installing and what port you need to open up, that will be mentioned here. But be careful while opening ports. If you really want it to be publicly accessible, then do it. Otherwise, no need to open the port. And here we put that we want the port to be available from all addresses. If we would put some specific IP addresses, so only those guys can open this particular port and access it. And here you can name like why you opened the port and what service, just for your reference. Even if you do not write, it would work, but it's a good practice. This is the web server port, this is the NetData port, and this is the SSH port. So we just wrote the description. Now comes the launch review screen. Here you can review again like whatever things you did, before launching, because once you hit the launch button the server would start provisioning. Then you cannot change these settings. I mean, you can change, but only after the server is up. So mostly it's good to review before launching. So everything is fine for us because we didn't make much changes other than the ports and the number of instances. And operating system is also fine, 18.04. So we launch. Now when we launch, last question is left. Like, we know that Ubuntu normally uses the Ubuntu user, so our username will be Ubuntu @ the IP address of that server. But what would be the password? All right, this question might come to your mind. How would we log in into the server? So normally the servers do not have a password. In cloud, passwordless login is practiced. What does that mean? That means there is a key pair that is generated. So using that key, we log in into the server. So there is a key in the server side and there is a key in the client side, and you use your SSH command with the key to log in. So that doesn't prompt you for the password in that case, and it is secure because only that person who has the key file can open it, not anyone. So even in password, like if someone just is eavesdropping and knows your password somehow, or somehow guesses your password, or uses a brute force software to get your password, then he might be able to log in. But if you have a key, there is no way to decrypt the key unless he physically accesses your laptop and gets the key, but that is a different scenario altogether. But any third person who doesn't have access to your laptop and the key can normally never access your server, so that way it is very secure. But in a case of a password, there is a chance that person might guess your password. So that's why cloud servers do not allow password login. You can tweak them to make a password login work, but we would not do that. Like, it's better to use key based login. So when I click on launch, then comes our screen to create a key. So here we can create a new key pair, or we can use an existing key pair. So let me create a new key pair so that you can go through the step. Like, it's just one step and very easy. But see how I'm doing it. Like, I'm just choosing create a new key pair, and I will put in a key pair name, DevOps. Let's name it something, DevOps practice key or something, .pem. So this is the extension. You cannot, I mean, you can choose not to write the extension. It would obviously add the extension automatically. So you put the key pair name and download key pair. So once you download that, you see there's a DevOps practice.pem which has been downloaded into our laptop. So this is very precious. Do not lose it. Store it somewhere where you do not lose it. Even if your laptop crashes, you should have your key somewhere stored safely outside your laptop. Because once you lose your key, there is no way you can log in into your server. So if it is a production server, then you need to be extra careful with your keys. You should store them in multiple safe places or vaults, wherever. Say if you want to store it somewhere in a safe place, like offline in your hard disk or somewhere, external hard disk or somewhere. But be careful, like no one should have access to your keys, because having your keys will give them a passport to enter any of your servers which use the same key. So we create a key pair, download it, and then we are given the option to launch the instance. So now you will see the instance will get started, and you can see this notice, your instances are now launching. Now if we look at view instances, we are seeing that it's in a pending state here. That means our instances are being provisioned, like they're being created, in other words. So at this point we can label our instances with the names. For example, this is my Ansible server and this is my Jenkins server. I mean, I'm just writing it for you to understand. I mean, it's not true that this is a Jenkins and this is an Ansible server. I'm just saying, say I have two servers, one is Ansible and one is a Jenkins server, and now these two servers are in running state and there is a health check still going on and says initializing. Once this health check passes, and it will say like it started and everything is fine. So now we can see the public IP address of the server, so we'll use it to log in. Actually, you can get more information about the server by clicking on the server and looking at the tab below. So here you can see the public IP, the DNS name of the server, the instance ID, or this one, and this is the internal IP of the server or the private IP, the VPC name, like the name of the VPC. So these two servers have the same VPC name, VPC 61681. So that means these two servers can talk to each other internally using this IP address. So this is how the demarcations are done and the servers are launched. Now let me just show you how to connect to that server, like how to SSH into these servers. So I'll SSH into one of the servers, so it will be the same for the other server as well. So let me go into the terminal now, and I'll SSH here. Now one important thing I would like to mention here is the system I am using is a Mac system, so which is essentially a Linux or Unix. So we can use the terminal here and directly SSH using the SSH command and the PEM file as the key. But in case you are using a Windows system, then you will have to SSH into your instance using a software called PuTTY. But when you are using PuTTY, then you would not be able to launch your PuTTY and log in using the PEM file. Okay, so in those cases you will have to convert your PEM file into a ppk file, .ppk file. So your key file has to be converted into a .ppk file, and that is done by a tool, and the steps are here, like you can search for them, like convert ppk PuTTY private key. So here are the steps. You can just go through and do the steps, like you have to download a software called PuTTY Gen and then follow these steps to create, to source your PEM file which you have downloaded, and then there is a converter and it will allow you to save a ppk file. So once that ppk file is there, you can use it to log into your server using PuTTY. So the steps to log in also for Windows, you can search and do it, like login to EC2 using, so you will get some documentation, official ones also. So here you can see with the screenshots you have the steps, so you can follow them, official steps. So using this you can log in, and in case you are doing it from Linux, Ubuntu, or any other Linux system, then you will be able to do it in the way where how I am doing it. Okay, so let's do it the Linux way. So let's go back to this. Now there are certain commands, you do not have to remember them. You can directly use this tool to right click and connect, and here you have certain commands. You do not need to do anything other than just copy this one, go into the place where your key was downloaded. So my key was downloaded in the downloads folder after I downloaded the key in the browser. So I'll just verify whether the key is downloaded there or not. So what was our key name? DevOps practice.pem. So here we are, we have the key. Now we run this command to set a permission on the key file to 400. So this is for security purpose. Once you set this permission 400, so this key will only be accessible by the user which I am logged in with. So my username is this. So only this user in this laptop will be able to access my key. So even if someone else uses my laptop and logs in with his username, he won't be able to see this file because there are no permissions for the group users and others. So it is only the read permission for the owner or this particular user. So we put that for security. So this is a one-time task. Like once you have put 400 permission on the key, you don't have to do it again and again. So this is a one-time task. Next is again to go back there and run this command ssh-i, then the key name, and then the user of the Linux is Ubuntu @ whatever the IP address or the host name of the server is. So automatically it will display the host name here on that command. When you right click and connect, you get that command snippet there. Or you can directly choose this IP address from here, copy it and paste it instead of this host name. So anything works. Now we click there, we press enter. It asks us whether you want to connect because this is a new server. So you have to add the key to list of known hosts. So that is done in the background, and now we are logged into the Ubuntu system. So here we are. Now we can run our installations or our commands. We can check our IP addresses. We can install Docker here and do whatever we like in this server. So, and this server would have internet connectivity, so you will be able to ping external websites from this server. And external people can access this server as well, only if we install the applications for which we have opened the ports. Like if we install Apache or Nginx, we will be able to watch it from outside because our 80 port is open. Or if we install NetData, we'll be able to watch it from outside because our 19999 port is open, and so on. So our aim is not to do the installation and all, so we'll do all that in our forthcoming sessions where we will be deploying CI/CD pipelines, and we will be deploying Jenkins and the entire infrastructure in the AWS cloud. So there would be certain tasks that I'll give you, and you will have to do it on your cloud account and send me screenshots or screencast recordings and so on. So that way you will learn how to do it on the cloud before you go in and work for a real world problem. All right, so this is how we create an instance and we connect to the instance. And let me also show you how we can destroy the instance. It's simple. Terminate. So it destroys everything, it deletes all the data. So when you never do it on a production unless you get a green from your superiors or whoever is signing off. And if you just stop the instance, it will stop it, but you will be charged for the hard disk and all that even when it is stopped. But if you terminate, you are no longer charged and your billing ends there. But in our case, we are using a free tier, so in any case we are not being charged. Still, I was just showing like how to terminate the instance. So this is how we do it. So while it is getting terminated, let's go back to our slide and we continue with understanding one architecture example where we will try to understand what a complicated architecture in using AWS service looks like. Okay, before we go into that architect diagram, like let's just have a review of the various services. Now it will make more sense to you. Now here in this slide, different services provided by Amazon are grouped together under headings. For example, coming from top to the top, like from the bottom to the top, uh, foundation services. These are the normal services which most companies would use, like we discussed. EC2, Lambda for compute serverless, and this is virtual machine. CloudFront is for content distribution network. For example, you have a website and you have lots of pictures on that website. So if the website is directly served from Nginx or Apache server, so all the pictures or images, folders and videos will have to be downloaded from your server all the time when your customers try to view your website. So that makes your website slow because the videos are streamed from your own server to all your customers, so they create their sessions and all that. So to make it easier, you can use CloudFront. So what CloudFront does is it takes your static content, images, videos and all, and puts it on a edge server which is nearest to where your customer is accessing it from and caches it there. So this caching helps other customers from the same region when they are accessing the same static content. It would be faster for them, and the website would load pretty fast because most of the content is cached in the edge location and it doesn't have to be served from the source server or the origin. So that's why this service is present here. Similarly, Glacier, Storage Gateway, DynamoDB, Amazon RDS, these are all common services. For example, DynamoDB is a Mongo server, MongoDB server, RDS is a MySQL, Redshift is a Postgres, Elastic Cache is a Reddish, and so on, different types of databases. Similarly, there are some network based services like S3, which is a DNS service, VPC for creating a virtual private cluster, or it's similar, analogous to what is a LAN in your office. And there is a direct connect service which is similar to what a VPN is, so that way you can connect your on-premise network to your cloud network. So similarly, there are other services in the application layer which allow you to manage your application, and there are services in the deployment and management layer. So you can go through the names of each services, read about them if you're interested, but presently you will be only concentrating on foundation services, so needn't go further at this point unless you master these and then move on. All right, so here this slide is for you to see. I would not be making much comments on this because I have already spoken about this. This is a short description on these services do. For example, Elastic Beanstalk allow you to do application and dev stack deployment. IAM services takes care of security and access control. Redshift is a data warehouse server, PostgreSQL, and so on. Route 53 is a DNS, and all. So this diagram is for helping you understand like what are the various services and what are they used for. So go through it when you have some time. Pause the video, go through this one, so you will get a lot of understanding what each service stands for. So that will help you understand and use these services when you're using Amazon cloud. But as I said earlier, normally you would not be using much of these services other than the foundation services: EC2, RDS, Route 53, uh, S3, and so on. So now comes the example architecture. So the reason of showing you this slide is to just make you understand that AWS architectures can be a combination of lots of services working together with synergy. So it is not just about one or two services working there. To make your web application successful, the architecture is designed in such a way that many services are involved and they work together under the hood. So if you are watching a website, in this case we have a website which is based on WordPress. WordPress is a framework, PHP based framework, which you can use to host your own website or blogs. So now this architecture is for a WordPress website which is highly available. That means there are multiple servers, and if one of them goes down, the website doesn't go down, it still is served from the other server. So that way this is a highly available architecture. Now how does this work and what are the various Amazon services here? Now just forget about the entire picture, just imagine the flow of the website first, and then I'll tell you about the components that are in use here. One is you have a lots of users who watch your blog or read your blog. Okay, so these are the users. They would be writing your blog names. For example, say your blog name is xyzblog.com. So these guys write xyz.blog.com in their browsers. So now that browser looks for the IP address of that translates to xyz via blog.com. So how that translation is done, that is done by a DNS server. So that request goes to an Amazon service called Route 53. There you have the record for xyzblog.com and its IP address. So once that IP address is resolved, that request goes to the CloudFront. If there is any static content that is served for the website, it is served to the users, and at the same time the rest of the content is served from the website, which is hosted in a EC2 instance. So this is a EC2 instance. Now since we want to make this highly available, we have multiple EC2 instances like 1 and 2 here. So that request comes, it comes through the internet gateway, because the connection from the outside world to your internal VPC goes through a gateway that is called the internet gateway, because otherwise VPCs are not allowed to be accessible from outside unless you have opened up a port in your security groups and you have an internet gateway in place that allows internal traffic to go outside and vice versa. So that request comes in through the internet gateway and goes to an application load balancer. So this is also a service which is provided by AWS, ALB service. So you can use a ALB when you have multiple multiple servers hosting the same website. So if you have two servers, you would have two different IP addresses. So what will the DNS register itself to? Like xyzblog.com can have only one IP, right? So if you have multiple IPs, in that case, it gives the IP of the ALB. So your ALB will have one particular IP. So your website resolves to that ALB IP. So the request comes into the ALB. Now the application load balancer or the ALB will forward the requests to any of these servers based on the algorithm which is set here. So normally these ALBs have a round robin algorithm where one request goes to server 1, second goes to server 2, third goes to server 1 again, and fourth goes to server 2, fifth again to server 1, and so on. So alternatively goes one here, one there, and so on. But there are other routing algorithms as well. One of them is least connections first. So there the traffic goes to the server where there are least number of connections at that point of time, and so on. So this is how the traffic is load balanced. Now in the back end, the servers connect to the databases, they connect to the caching layers or the memcache, because this is PHP, there might be memcache here which allows you to serve your network faster and your website faster, and so on. There are other components involved here like NAT gateway. NAT gateways are used to connect or port forward internal applications to the public subnet and so on. So we'll talk about all these later. For now, I just wanted to show you like how complicated, I mean, this is not even very complicated, you have more complicated architecture than this, but I'm just showing how a complex or a highly available architecture looks like in AWS, and how multiple services come together to work and make a website or a web application successfully hosted. So there are lots of tools here. So once you start learning about them later on, you will be using them. But from a DevOps perspective, you have to just know the high level things right now, because you would be more practicing on your DevOps practice like deployment, pipelines, and Jenkins, infrastructure as a code, Ansible, and all these stuff. Once you master them, you can go and learn some Linux and learn some cloud computing and go into more depth of creating infrastructure and well architected frameworks. Once you're done with that, then you can pick up one programming language like Python and all these. There are lots of things you can do to enrich your knowledge from now on. But once you have started your journey, you're always going to get to a better place than what you are right now. So keep learning and keep exploring and go through your dashboard, create an account, and explore AWS more. It's a wonderful cloud service, and you will learn a lot working on Amazon Cloud. So thank you for your time today. Have a great day.